Hi, my name is Matt Peterson. I'm an associate professor here at George Mason University in the psychology department and the neuroscience area also. And I do a variety of research that has something to do with attention, if you will. So I do a variety of work on attention, particularly visual attention. I actually use quite a variety of techniques. I do some neuroimaging stuff. I do a lot of eye tracking. I do basic theoretical research, and I also do some applied research. One of the nice things about using eye tracking for research is that it allows us to track attention on a moment-by-moment basis. So you get a better idea, at least in real time, what people are thinking and what sorts of information they are processing. One of the things that we're looking at is a real-world application where we are trying to use patterns of eye movements to predict a person's situation awareness and whether or not they actually are aware of what is on the screen. One of the techniques we use is that it turns out when you make a rapid eye movement, which is known as a saccade, your visual system actually shuts down and you're functionally blind. What that means is, if you have a high-speed eye tracker and a high-speed computer, you can change things while the eyes are in flight and people won't see the change itself. What that means is for people to notice that there's a difference, they must have encoded the information in the display beforehand and be able to compare it after their eyes stop moving. So we can use this technique to see how much of the display and how much of their situation, if you will, they're aware of by looking at their patterns of eye movements to see if they have changed and whether or not their eyes show us that they've noticed that something has changed about the display. One of the studies that my lab is currently involved with is a study that we're doing with Wright-Patterson Air Force Base in Dayton, Ohio. And what we're using is a lot of our tasks that we do are laboratory tasks. And we try to strip them down, we try to make them as basic as possible to get rid of any confounds. In this case, what we're using is one of their UAV, unmanned aerial vehicle simulators, to go in the opposite direction and try to make these tasks as realistic as possible. And when we're using this change detection type of paradigm, eye movement type of paradigm, to be able to look at what people are actually aware of when they're doing these complex tasks where different objects are flying around and when they have to interact with all sorts of different things.